Hi all, welcome to the video. In this video, we will look at a simple illustration of how we can score continuous or numeric data, and for this we have taken a very simple example. And what I have done is I have taken 12 points which are from 2 to 20, and these are not continuous in the sense that they are not they are not through an increment of 1, but they are separate from each other by, let's say, more than at least 1 unit. So these numbers are 2, 3, 4, 5, and 6, 7, 8, 10, and then 11, 14, 17, 20. Now, in the last video, we saw that there are certain cluster of points that are close to each other. We say that these points are normal, and then there are certain cluster of points which are far away or which are very isolated or discrete. These points are normally, what we call outliers or anomalous points. So I think you must have already imagined that the first step in basically implementing this algorithm is to find the total number of buckets or total number of clusters. So there are 12 points. So roughly, if I take the square root of 12, which is around 3, then we say that these are divided into, you know, 3 buckets. These are 12 points, each are divided into 3 buckets, and within each bucket there will be what? 4 points. So there are 3 buckets, which is equal to square root of 12. Now within each bucket, and let's call ns, let's call 12 as capital N, and within each bucket the total number of points are n divided by, let's call square root of 12 as k. Okay. Now, just for simplicity's sake, let me color them. So these are the first bucket, this is the second bucket, and this is the third bucket. Okay. Now, just a second, let me just pull it a little down. Okay. Now, width of the total bucket. Now we can see that this spans from 11 to 9. So I can say that this has 9 points or 9 units. Similarly, for this bucket, this is basically from 6 to 10, so this is essentially 4, and then this is from 2 to 5, so this is essentially 3. Okay. Now there is a concept of area. Let's say if the 3 buckets have the same set of numbers, then basically we are basically dealing with certain buckets, and each bucket or bin must have certain area. Now we know that area is constant. Let's assume that all of these have the same area. Same area means the total number of points, which is 4, is constant. Okay. Now the only different factor is, the height, because see, base width is already defined. Just a second. So width is already defined. First bucket has the width of 3, second bucket has the width of 4, and third bucket has the width of 9. Area is same. Now height will be equal to what? Will be equal to 4 divided by, say, 9. Okay. Let me parameterize. Okay, and this will be okay. So you see, let me see as values. So we have calculated the height of these buckets. As you can see, all the points within a given bucket or a cluster will have the same height and the same area. Width will vary. Then let's calculate the normalized height, which is nothing but this, each divided by the maximum. I think maximum is 1.33333. Okay. And let's make it as 1, since we already know that the number is same. So now we have calculated the normalized height. Now the score will be equal to, so points within a single bucket will have the same score. So this will be equal to nothing but log of this normalized height. Okay, then now you see the bucket, the first bucket which is highlighted in yellow has a 0 score. The second bucket which is highlighted in sort of gray has minus 1.2 as the score, and the third bucket which is highlighted with the cream color has minus 0.47 as the score. Now intuitively, if you see, there are, in the first bucket the width is only 3, in the second bucket the width is 4, and in the third bucket the width is 9. Of all the buckets, the bucket with the minimum width will have the least score. I mean the maximum score. The bucket with the uh, what you can say highest width will have the highest negative score. So in the sense that bucket or a bin containing the maximum span will have the highest negative score or will contain points that are anomalous in nature, and the bucket with the least span or where points are tightly clustered together will have a very positive or a favorable score. So this was a very simple Excel illustration of how we can basically with a small data set, how we can actually conceptualize starting from identification of the bucket, which is the square root of the total numbers, and then we identify the height, and then we normalize the height, and then we basically take the log. Uh, in the next video, we'll look at how we can implement this algorithm in R. And subsequently, we'll also see how this algorithm works if we scale the number of records to 1 million. If the video was useful to you, do subscribe to my channel.